Hey guys, this is Mrs. Haney back with another lesson on predicting with probability. So sometimes you use probability to make a prediction based on the theoretical probability. Um, think about like meteorologists. Meteorologists, they use data that's actually given to them, so it's not theoretical, but they do use that data to make predictions. So they get models of similar conditions and they predict weather by using those models. So sometimes we gather data to help us make predictions. Like back in the day, they used to send people door to door to get information, and they would take that information back and make predictions based on the population that currently existed. So, anyways, how to use probability to make a prediction? Well, step one, you find the probability of the event. Step two, you set up the proportion using probability. And then step three, you solve for the unknown where you cross multiply and divide. I already wrote this stuff down, so feel free to pause this video because I'm just going to continue on. All right, this first example says a hot dog company surveyed 100 people in a town of 1,200 to find their favorite grilled foods. Predict how many people in the town prefer each grilled food. So if I look, the first section is hot dogs, and then the second one is steak. So I'm going to gather my information here. So I know that there was 100 people they surveyed, and then the town itself has a population of 1,200. So it wants me to calculate hot dogs over total. So I'm going to use the probability information first. So if I look hot dogs in the table, they had 22 responses out of 100. So I'm going to write 22 over 100 equals x over, because that's the part that we don't know, over 1,200. So this is a proportion. We're just going to cross multiply and divide. So we get 100x equals, and then I would do 1,200 times 22, which if I go through that process, it gives me 26,400. So 100x equals 26,400. I'm going to divide both sides by 100. Now remember, if you have zeros, you can cross the same amount of zeros down below and up top. So you end up just getting x equals 264. So we can expect 264 people in the town to prefer hot dogs. Now, it may not be necessarily that number exactly, but we can expect that number as an estimate. All right, now for steaks. So, oops, that S did not turn out. So it's steaks over total. So if we look at the table, steak had 19 responses out of 100. So I'm going to write 19 over 100 equals x over 1,200. Remember, always keep your totals on the bottom. So now I'm going to cross multiply. So I end up getting 100x equals, and then I would do 1,200 times 19. And if I go through that process, I get 22,800. So I'm going to write that down here, 22,800. Divide both sides by 100. Again, I can cross out the zeros. So now I just have x equals 228. Again, it's not an exact number, but it is an estimate. So we could expect about 228 people to prefer steaks in the whole town. Okay, on to the next question. It says a principal randomly chose 40 students from 7th grade. Of these students, 9 were wearing watches. Based on this information, what is the most reasonable prediction of the number of students wearing watches in a group of 120 students from grade 7? Well, I know that the principal chose 40 students and 9 of them were wearing watches. And then they want us to make a prediction, because it literally says prediction, in a group of 120 students from grade 7. So I'm looking at watches. Always use your words first. Over total. So I'm going to put what I know first from the survey. So there were 9 students wearing watches out of the 40 he surveyed. And then the prediction side, we want to know how many out of 120. Okay, so now I'm going to cross multiply and divide if necessary, which it is. So I get 40x equals, and now I have to do 120 times 9. Okay, so we have 0, and then 9 times 2 is 18, so I have 8, carry the 1. 9 times 1 is 9, plus 1 is 10. So I get 40x equals 1080. Okay, now I'm going to divide both sides by 40. And again, if I have any zeros to cross out, I'm going to cross them out. So I can cross that out, and now I have 108 divided by 4. And if I go through that, I get 27. So A is my answer. Okay, next one. A cafeteria manager surveyed a random sample of students at a school to determine which of 2 meals they prefer. The results of the survey are shown below. Chicken is preferred by 30 students. Pasta is preferred by 18 students. Based on the results of the survey, how many of the 240 students at the school can be expected to prefer chicken? Sorry guys, a little tired today. Okay, so we're looking at chicken over total. So I know that chicken's preferred by 30 students, so I'm going to put 30 on top. But how many students were surveyed in total? Well, you have to add 30 and 18, and that gives you 48. Sometimes you're given the total, and then sometimes you have to add to get your total. It just depends on the situation. Okay, and then on the other side, we're going to put 240 on the bottom because that's the total, and then x. So now we're going to cross multiply and divide. So we get 48x equals, and now I'm going to find some space to multiply. I'm going to zoom in really big. So I have 240 times 30, 0, 0, 0, add my 0, 0, lots of zeros, 12, so 2 carry the 1, and then we have 6, 7, so we get 7,200. Okay, so we have 48x equals 7,200. Now I'm going to divide by 48. And if I go through that process, x equals 150. So if we were, we could expect 150 students out of the 240 to prefer chicken. Okay, if you have not yet, go ahead and flip your paper over. We're going to do just a couple on the back side. So let's take a look at this very first one here. It says Tyler rolls a pair of dice. The results of each roll are shown in the table below. So he rolled 2 dice, and these numbers in the table show like one rolled, like for example, the first one rolled on 2 and then the second one rolled on 4. All right, so it says if Tyler rolls the dice an additional 175 times, approximately how many times should he expect to roll 2 even numbers? So now we got to go back to the table and look and see where we have 2 even numbers. So I see we have 2, 4, and then we have 2, 2, and 6, 2, and then we have 4, 4, and we have 2, 6, and 6, 4. And those are all the evens that I see. Now, I need to know the total number of times that he rolled here. So if we look, we have 1, 2, 3, 4, and then 1, 2, 3, 4, 5. So that's 20 total. Remember, you got to get a total. And then of those 20, we have 1, 2, 3, 4, 5, 6 even. 6 where both are even, I should say. It's always okay to take notes. Okay, so anyways, we're going to do our words first here. So we're looking for the evens over total. So I'm going to use the given information. Well, I know 6 out of 20 were both even, so I'm going to put 6 over 20 equals x over 175. So I'm going to cross multiply. So I get 20x equals, and then I'm going to do 175 times 6. So I'm going to zoom in because I need space. 175 times 6. So that gives me 30, carry my 3, 42, 43, 44, 45. So 5, carry the 4. And then 6, 7, 8, 9, 10. So I get 1050. So 20x equals 1050. Then I'm going to divide both sides by 20. 0 pair. And then I can cross out those zeros. So I end up with 105 divided by 2. And so that actually gives me 52.5. So we can make an approximation here and expect it about 53 times. Okay, we're going to skip this one about Philip rolling a standard number cube. And we're going to take a look at this one about beads. It's the last one on the left side. So it says a bag contains 6 white beads and 4 black beads. You pick out a bead at random, record its color, and put the bead back in the bag. You repeat the process 30 times. How many times would you expect to remove a white bead from the bag? So we're looking at the white beads. So I'm going to just write white over the total number of beads that are in the bag. And I'm going to write 6 for white, and then I see I have 6 plus 4, so I have to find that total, which is 10. So I have 6 over 10 equals x over, and it's asking if you repeat it 35 times, so I'm going to put 35. Now I'm going to go ahead and cross multiply. So I have 10x equals, I'm going to do 35 times 6. So that gives me 30, 18, 19, 20, 21. So I have 210. Divide both sides by 10. Cross out those zeros. In this case, I have x equals 21. All right, we're going to do just one more, and it's this last one. So just scoot over to the right side. Okay, it says a survey reveals that one airline's flights has a 92% probability of being on time. Out of 4,000 flights in a year, how many flights would you predict to arrive on time? So I'm looking at how many are on time because the rest of them are not on time. So on time over total. Now, I know that 92% out of 100%, because 100% is the total, is on time, so 92. And then the other total is 4,000. So 4,000 goes on the bottom. And then X up top. Now I'm going to go ahead and cross multiply and then divide where necessary. So I'm going to write 4,000 times 92. And I've already done that one, so it's 368,000. All right, so I'm going to write 100x equals 368,000. And then I'm going to divide both sides by 100. I'm left with x on the left side. I'm going to cross out two sets of zeros. And so I have x equals 3,680. All right, good job solving probability or predicting with probability.